Hey everyone, let's focus today on how overvoltage damages motor insulation and leads to burnout. Excess voltage is one of the fastest ways to destroy a motor, especially if the system lacks proper protection. How overvoltage damages insulation and burns out motors. Electric motors are designed with a specific voltage rating, and their insulation system is built to withstand only a limited amount of electrical stress. When voltage exceeds this limit, the insulation starts to break down, setting off a chain reaction that can lead to complete motor failure. Here's what happens when overvoltage occurs. Increased electrical stress on insulation. Insulation in motor windings is designed for a specific dielectric strength. When the voltage goes beyond the rated value, the insulation experiences excessive electrical stress, causing it to weaken over time. Excessive heating and thermal runaway. Higher voltage leads to increased current in the windings, generating excessive heat. Since insulation materials degrade faster at high temperatures, this accelerates failure. If the motor does not have sufficient cooling, this can quickly lead to thermal runaway, a condition where the heat keeps increasing until the insulation completely fails. Breakdown of winding coatings and motor burnout. Over time, the insulation on the copper windings deteriorates, exposing the bare conductors. This results in interturn shorts, phase-to-phase faults, or phase-to-ground faults. If left unchecked, these faults cause an immediate spike in current, leading to motor burnout, the classic fried windings failure mode. What causes overvoltage? Overvoltage doesn't just happen randomly. Here are some common culprits. Power surges from the grid. Sometimes the electricity company cranks up the voltage without warning. Your motor? It just has to deal with it. Lightning strikes. If lightning hits nearby, you can bet that your electrical system is getting a voltage spike. Bad wiring or transformer issues. Ever connected a 400V motor to a 480V supply? That's a disaster waiting to happen. Human errors in motor connection. Mistakes in wiring can lead to severe overvoltage damage. Some common errors include connecting a 120V rated motor to a 220V supply can instantly burn out the windings. The role of overvoltage protection. If a motor circuit has a proper overvoltage protection system, it should detect and mitigate excessive voltage before it can cause damage. This includes surge arresters and suppressors to absorb transient voltage spikes, voltage monitoring relays that shut down the motor if voltage exceeds a safe threshold. However, if the circuit lacks protection or if the protection system fails, then overvoltage will affect the motor. The extent of the damage depends on two factors. Voltage magnitude. A slight overvoltage may cause gradual insulation wear, but a severe overvoltage can lead to immediate failure. Duration of overvoltage. Short-term overvoltage may cause temporary overheating, but prolonged exposure significantly weakens insulation and increases the risk of total burnout. Preventing overvoltage damage. To protect motors from insulation failure and burnout due to overvoltage, consider these best practices. Ensure the motor circuit has reliable overvoltage protection. Regularly test protective devices to ensure they are functioning correctly. Monitor voltage levels using power quality meters or voltage monitoring relays to detect sustained overvoltage conditions. Properly size and maintain surge protection devices to handle transient voltage spikes effectively. Check transformer tap settings to ensure the supply voltage matches the motor rating. Regular insulation resistance testing to detect early signs of insulation degradation before failure occurs. Final thoughts. Overvoltage is one of the most dangerous conditions for electric motors because it directly attacks the insulation system, leading to failure and burnout. While a good protection system should prevent damage, a lack of protection, or a failed protective device means the motor is at risk. The higher the overvoltage and the longer it lasts, the faster the insulation breaks down and the sooner the motor will fail. Have you encountered a motor failure due to overvoltage? What protection methods do you use in your circuits? Let's discuss.